Alright guys, now let's talk about enum classes. So you'll often find yourself dealing with constants that do not change. So instead of declaring a string constant, you could declare them as enum constants. So enums are not exactly string, but they are kind of like a class type. So in order to declare an enum, so let's declare an enum called type. And let's have some types there. You can give them any type. So we will name them info, error, and then debug. So these could have any types. Oh, I forgot the class keyword here. So enum class type. And then finally, you can just use them, the way you want to, like define them give them some values. So keep in mind there is only just one instance of this. So whenever you use the type.info, it's only one instance. So let's define a type here of type.info, just like that. And if you go ahead and print this, this will just print info. So, and you can just use them in your when statement, is an if statement, and the way you do a comparison is like if type equals type.info, do something. So println info is here, else let's just print something else, right? And so basically the idea is to just show you that this is how you do the comparison operator using an enum, and you could use them in your program and give them as many enums as you want. There are other things you can do with enums. One is you could give them some, so let's say I want to define a message for this type, so you can give them a type of a constructor. So let's give them a message, and that'll be of type string. Let's fix the spelling here, and then use that class as a constructor. So this is info, and then give some respective messages for your error, and for your debug, I'm going to put in some messages as well. And the way you would access them is essentially just use, so let's go ahead and print one. And then what we're going to do is we'll just do a type dot info, and then the constructor parameter that you passed. So I'm going to just pass message. So message refers to this is info. So if I print this, it's just going to print this is info. So you can make them hold any type of data. In this case, I'm just making them hold string. Also, one of the most useful features is you can make enums declare abstract functions in it. So let's say I want to have an abstract method in here, and I will call it get signal. Right, it'll have a return type of string. So as you can see, there are squiggly lines. It's basically asking me to implement the member. So just like a class, I declared an enum, and then I gave it an abstract method. And these enums that I have declared here with the values that won't change, it's just asking for me to implement the members, and I'll go ahead and do that. And I'll do the same thing for error as well. And I'll do the same thing for debug as well. And then you can just give in some value here. So do a return. We'll call this just info signal. Oops. If I could just type. And then the same thing we would do for our error message. We'll call it the error signal. And for debug, we'll do the same thing as well. One thing to keep in mind is whenever you're done declaring your enum, just close it with a semicolon like this, or it won't compile. And And the way you would access the signal method is essentially just like you do in a class. So let us create an object of my enum type, which will be type. You can define the type here, or you don't have to, but just putting it just for that. And then type dot, let's do a debug, and let's print the message and the signal. So print ln, and I can do a type dot message. So message is going to print just the message in it, and the signal you can just access it just like a method in it. So this enum has a type get signal abstract method, which is implemented by the type debug. And let's go ahead and run this. So this is a debug message, and it prints the signal as well. So enum classes are fairly useful. It provides certain methods in it. So if you define something of type, you can get the entries for it. So let's get the entries for the enum, and we're going to take the type dot values. It is going to return a collection, and let's use a for statement, let's use a for loop to print that. So I will do an entry in entries, and I'm going to go ahead and print ln the entry. And when I do this, it just prints the entries with the values for it. I could call the methods on it, so it's just going to print all the signals for all my enums, or the values, the one that I assign a constructor. So I could just print the messages, and that's pretty much it. Enums are fairly useful, so make sure you understand how they work, and keep in mind that with enum there's only just one instance when you create them. Alright guys, now let's talk about seal classes. Seal classes are pretty much similar to enum. The only difference is you can create different instances of seal class. And a popular pattern is to return a result type, or you can just use seal classes just like this. So let's create a seal class called result. And just like we define types in enum, we can define types here. So let's say here we're going to return a result called info. We'll call it object info, and the return type will be result, which will be the seal class type. And let's also return a type called debug. You can also return data types, data class types here. So let's return a data type called error with a message. And if you define a data class, you will have to define the constructor there. So we will give it a message of type string, and the return type again will be result. And the way you use seal classes is essentially just like, so you'll execute a business logic and you will return something from there. So let's create a function called getResult, and the result type here we are going to define as type result, the seal class type, right? And then we're just going to do a return result.info. That's it. So you could return this type, or you could return something like error, since I am defining an error as a data class. So there will be a message. This is an error. So in real time application, you'll define a seal class like this, and then you'll execute some business logic, like maybe a web service or read from the database, and then you'll return a result. The result could be result.error or result.info or debug or something like that. Now the way you would read this is you could just do a result here, and you could do a when statement here. So when I'm going to call in the method here, get result, and then put this, and then I am going to check what the result type is. So in this case, if it's a result.error, then execute some logic or do something. So in this case, I'm just going to print and then I'm going to add more blocks here. If the result type is info, I will just print something here. And obviously if you do not define an event statement, if you do not define all the cases, you would have to end it up with an else block. However, here I want to define all the cases, so I have info and then the other one is debug, so I'm going to define that as well. Now I don't have to define the else block. That's pretty much it. So all I'm doing here is just returning some result, and I am going to print this result. Oops, if I could just type. So I'm gonna name this my fun main. It has to be a function that I'm executing code in. And since I am returning an error, it's an error. If I want to access the message of what the result was, here I'm just executing this, it's an error. If I want to access what the result message was, I could just access it using the start message. So what I'm doing is I'm getting the result, assigning it to a parameter, assigning it to a variable here, and then using this res variable along this. Now because this is error and I have a message defined in it, I'm able to access the message in it. If you define it, if you check it in the info type, you won't be able to see the message, or because info is just an object, it's not data class or anything like that. So if I try and do this, there is no message class here. Essentially, this is what you would use seal class for, mostly to define different types of result, or use it in some other functionality. It's fairly useful, just like enums, but you can create different instances. Alright guys, in this section, let's take a look at the object keyword in Kotlin. So we've already seen that you can declare anonymous implementation of an interface while it being a return type of a function. So let's just refresh that. So let's just create an interface here called humanoid, and let's have a function in there called do humanoidy things. Oops. What we're going to do is let's declare a method here which just gets some stuff. And let's give it a return type of humanoid. Right. And actually, let's give it a parameter of humanoid. So let's declare a function here. We will call it our cool function. And what we're going to do is we will give it a parameter type of our humanoid. So this will be, there you go. So what you can do here, you have two choices here. You can declare a solid class which implements this interface and then return it, and then call this function. And we're just going to do something here. Let's make it do some work. And let's do $, and then do humanoid things. So this is So this is basically, we have defined a framework, a cool function. It basically takes a parameter of type humanoid and it does just do humanoid things, but we haven't defined any implementation. So if we make a main function, what we're going to do is we're just going to call our cool function, and we're going to give it an implementation type. So this will be an object, which will be of type humanoid, and then we're going to declare stuff in it. So we're going to implement our function here, and we will just, this will be an override. Oops, we're going to delete that. And we're just going to add a println, do some cool work. That's about it. So all we're doing is we just created a main function and we are calling a cool function here, and we're giving it an object of the type humanoid. But since we don't have a solid implementation, we decided to make an implementation right there and then and use the object keyword there to do that. So this is one way you can make this work. Other way is when you can define a class that extends or implements the humanoid class. So we'll have our human from earth class, and we're going to go ahead and make it implement the humanoid, and then finally give it some implementation. We will implement the members and make that work that way. But the purpose of this is to just show you what the object keyword does. There are other uses of the object keyword here. So one is creating singletons. So you could create object classes here. Let's say a database connector. So when you declare a class like this, so it's essentially an object class, and the functions that you define here will have just a single instance throughout your application. And that is one of the reasons why you would use the object in front of a class name like this. And the way you would access it is pretty straightforward. So let's just create an object here. We'll call it our database, and we will just use a dot operator to connect. And that's it. Obviously you'll have some functions doing some work here. So essentially this is the way you would create a singleton in Kotlin. The object keyword is pretty cool as well. You can use it for other implementations like creating just classes. So let's say I want to create another object, but I do not have a solid class for it. I could just do an object just like that and then make this do some work. So a is equal to 2, something like that, and then have functions in here as well, do some more work. Pretty much like that. So I did not create any class, but I used the object keyword to just declare something and do something, and you can actually make a call outside like this and get access to the variables, or just you could use it just like a class. And that's the usage of the object keyword, just to create anonymous implementation for your interfaces, or use it like a singleton, or just create an object when you just need a simple object without doing any heavy duty class work. Alright guys, in this section let's take a look at inline classes in Kotlin. Now, sometimes there is a requirement where you'd want to wrap some business logic in a wrapper of some type, and you'd want to specifically do this because you want specific types for it. Let's see what I mean by that. So let's say we have two functions which has get employee information. We'll call it a get employee info, and it is going to take in a string parameter. In real life, obviously, this will be something more complex like a UUID or some sort of a unique ID, but here we're just going to call it ID and it'll be of type string. And here we have some business logic, either to make a web service call or a database where it fetches this information for an employee. We have a similar method for this to get an organization info. Just like that, and it also takes an ID, and it does get organization stuff. Now, if I make a call to any of these functions, and I'll have to pass in an ID, which is of type string. So let's create an employee info. So we'll call it e-info, calling employee info. And we are going to do get employee info, right? Just like that. And we will pass in a string. So let's also create two IDs, fake employee ID of some, just put in some value in there, and we'll also have a fake org ID, which is the organization ID. So just bear with me, it'll get clear what I'm trying to do here. So if I try to fetch employee info and I pass in the fake emp ID, this works fine because I'm sending in an ID. However, I could also make the mistake of sending in an organization ID and calling the employee method, but I'm sending in an organization ID. So that is obviously, it might create issues, or you might just not find any information, and there might be exceptions thrown, so on and so forth. So there is no compile time check for this. In order to solve problems like this, there is a type called inline classes. So you could technically make solid classes, solid data classes for these, and then wrap it up and send it of type employee and then type organization, but that has some compiler overhead. So it's not really too efficient to handle that situation. So to solve this issue, we will define a class called a value class. In order to do that, we'll use the keyword value. We'll call this employee ID. And we will define an ID here, which will be of type string. And we'll also annotate it with the JVM inline, letting the compiler know that this is a value class, which means under the hood, it is going to operate as a string, but we are defining specific type for it. We're going to do the same thing for the organization ID, and we will call it org ID, just like that. And now the parameter type, where for the employee, we're just going to make it an employee ID. For the organization, we're just going to call it an organization ID. And everything seems fine now, but however, I get a compile time exception saying that my get employee info method does not accept a string parameter, obviously because it has to be wrapped with this employee ID. So I'm going to create an employee ID just like that. And with the org ID, I'll do the same thing. Pretty much just like that. Now, if you see the get employee info, it's telling me that it's expecting an employee ID, but I'm actually sending an org ID. So I'll have to send it an employee ID. So this is essentially what inline classes are. They kind of give you compile time checks of certain types without actually creating a class for it. So under the hood, under the compiler, when it gets compiled, it's like this. So when it generates the fake ID, so I'm just going to comment this just to make sure that it does not cause issues. It is essentially getting generated just like this. It is treated as a string. However, it gives you a compile time check that when you send this information to the employee info, it gets the employee ID type, and the same goes with the org ID. So I can call the organization ID with the org ID and not with the employee ID. If I try to do this with the employee ID, it's going to cause a compile time error again. So let's try and send the fake employee ID, and that's not going to work. So I have to send in the org ID, and now everything's fine, and we can wrap this up in a specific type of object. So that's what value classes are meant for. Now there is a counterpart to this called type aliases. So let's say for string, I want to define something known as type alias. So the way to define a type alias is like this. And I can define, let's call it emp ID is equal to type string, right? Now this emp ID is essentially a string, but I'm just giving it an alias. So I can define a string type. So let's just comment this code so we ignore it. And here, if I try to define an emp ID of type emp ID, which is essentially a string, and I can just give it some string just like that. Now, if I try and call the employee ID with this emp ID, that is not going to work, because keep in mind this is essentially a string, so that the employee ID thing, the employee info method expects an employee ID value class. So it's of the wrapper that we had defined previously. However, let's say if it was taking a string and we are passing in a string here. So though I have defined it of type string emp ID, it is still taking the emp ID here because I have defined it as a string. So emp ID and string are the same thing. So I can define it, I can use either or. So I can use a string just like that. So, but there is no compile time exception. So if I also have the org ID defined as string, and if I try to call this method, that is gonna work as well, because that expects a string, and the string emp ID is of type emp ID, which is also a string. So just take some time and think through this. Essentially, there are two things: type aliases, where you just define an alias for the type, and then value classes, where you kind of define the type, however you wrap it with a thin wrapper.